Greetings, dear friends, fellow programmers, and those aspiring to be. I have a question for you. Are you still eager and ready to advance your knowledge about dependency injection in ASP.NET Core? I thought so. You are always eager to learn and grow and become an amazing developer. And this video series will help you achieve just that. Basically, that is exactly why I have prepared a new variety of different advanced dependency injection concepts that I think you should be aware of. And I promise I will not waste your time any longer. We can proceed to our first advanced concept of the day. I'm talking about using factory methods for instantiating complex services. What is this advanced concept all about? Well, imagine the scenario that your dependency injection containers require some assistance from our side in order to be able to instantiate some complex service. Because it is just not able to figure out everything on its own, and it needs some explicit definitions and basically us pushing it in the right direction in order to be able to do the rest of the stuff for us. So this scenario I'm talking about is very commonly used and found in code bases, and also I was personally struggling to find explanations about it and how it works in my personal life. I think it's a great opportunity for you not having to struggle the same way I did. So why wait any longer? Let's jump to our Visual Studio and see what I'm talking about. And welcome to Visual Studio, where we are ready and eager to learn and master additional advanced concepts of dependency injection. So we're right away jumping into program CS file, because that is where we need to live right now. That's where we are doing all the magic dedicated to our more complex scenarios for defining services and their instantiation processes. So what we have here is a MyService interface for which we need to provide configurations from the configuration in order to be able to instantiate a concrete instance for this interface. So what we are doing is we are fetching a service for iConfiguration, which is going to give us access to the configuration files of our application. Then we are using getValue method on the configuration to fetch myOption value from the configuration file, and then use it to pass it to constructor of MyService instance, and then use that option value and send it to constructor of MyService concrete class. So basically MyService concrete class inherits from MyService interface, and it has a private field called configuration, and in order to create a new instance of MyService, we need to provide it with options which we just passed in our program CS file, so we will receive it right here, set the value, and we do not care about the implementation. So basically, that is how you would handle more complex instantiation processes for your services. This part right here can be anything. There are so many different scenarios where you need to work with different configurations, options, and things of those sorts in order to be able to create a successful functional instance of some complex class. And that is where you will be using factory dependency injection services. After we have mastered that concept, it is time to talk about decorators. So, as the name suggests, these decorators in dependency injection containers in ASP.NET Core are heavily relying on the concept of decorator design pattern. They will allow you to decorate certain service with additional functionalities and allow you to basically introduce something on top of the base functionalities. So in the case I will be talking about in this video, we will introduce caching values on top of just regular fetching from the database, because this is a very common and very useful scenario that you can use in your day-to-day life. So let me show you what I mean. When we go back to our MyService class and take a look, we have an interface. Then we have MyService implementation, which is the base implementation. And also we have caching service decorator, which again implements MyService interface. And inside of it, we have two private fields. We have MyService, which is called inner because it will basically address the instance of MyService that we will have right here and its implementation. And also, because we are working with caching, we want to have iMemory cache instance. We just inject those two values through constructor, and then we can proceed to the actual implementation. If you remember, we had getData method in our interface and also in the initial implementation of the service, so we need to implement it right here as well. And what we are going to do is basically try to get value from the cache where the key is called data. And if the data key exists and there is some value attached to it, then it will return it inside of this variable data, and we will return it from the cache. But if it does not exist, we will then invoke the regular implementation of MyService service and invoke the getData method from it, which is basically going to be this implementation right here. So it can be fetching the data from the database, and because we want to evade doing that and investing resources and waiting time into calling the database, putting pressure on it, we're going to perform it only when we have to. So we will fetch the data from the database, let's say, and when we have done that, we will set a key in our cache memory on the key which is called data, which is the one we are trying to fetch here, and we just define how long this cache key should exist before it expires. When after it has expired, even though we have populated it, it will basically be erased and no longer be available, and we will have to fetch it from the database again. This right here is a very common scenario, and I personally like to introduce it on the layer of repositories in my code and have actually the capability inside of my repositories to get cached value for certain things, which are very heavy-duty manipulations with the database and which require a lot of effort to fetch the data and prepare it from the database. So I just save the results I fetched initially in the cache memory, and next time I check whether we already have the data in cache, so we do not have to bother the database. So this example is a real-life scenario. Okay, now that we have actually discussed how this caching decorator service is created and implemented, which is straightforward, right? It is time to talk about the actual topic of our video, which is how you can register it so everything works as expected. So what we are going to do is first we need to let our pipeline know that it should have memory caching included. So we're going to introduce the middleware, which is going to be used for memory caching. Then we need to register our regular service, which is going to be MyService implementation for MyService interface. Then finally, we need to create the decoration of it. So we're going to do that by introducing another add transient statement, and we just specify the interface on which we want to provide this decoration, and then we use the service provider to create a new instance of caching service decorator class, and we need to pass two instances to its constructor. If you remember, we need MyService instance and iMemory cache instance. So we need to create those two, which is going to be done in a fairly straightforward way. We need to use getRequiredService method for getting the MyService implementation, and also to getRequiredService for iMemory cache. And because it's a built-in functionality in ASP.NET Core, it will just automatically know what to do for us. And basically this right here is everything you need to do to have everything set up correctly. And finally, I have another advanced scenario, which is utilizing dependency injection, that is going to be covered in this video. I'm talking about creating different HTTP client instances with custom names that we can assign to them. And welcome for the third time in this video to our Visual Studio environment. And in this case, we will be talking about introducing custom HTTP clients in our project. So, as we mentioned, we can name them whatever we like, and that is going to be done by providing this name parameter to add HTTP client method. So we're going to call it GitHub client, because why not? And then we need to configure it. So we need HTTP client instance. We're going to use Lambda expressions, of course. And then we need to set the base address, which is going to be api.github.com. And we also need to set the default request headers, which are required in order to be able to use this HTTP client. So when we have done that, we have successfully configured our custom HTTP client. So let me show you the service itself and how we can use that HTTP client in our code. So we're just going to create a private field, which is going to be of type HTTP client. And then in our constructor, we need to use HTTP client factory, which is a way better practice than to use a regular instance of HTTP client, and then use that factory to create a client with the name we provide, which is going to be exactly the name how we basically named our custom HTTP client. And right now we can use that client to fetch whatever we like, and everything should work exactly as expected. I know this video might have been a bit tougher than expected, but trust me when I say this. If you invest some time and effort to master this and apply it in action, in a few months this is all going to be a part of your regular day-to-day life, nothing special, nothing to write home about, just regular stuff you do because you are going to be an awesome developer. So I hope you've learned a couple of new things along the way, and if you enjoyed this video, I would like to invite you to subscribe to the channel because it really means a lot to spread the word to as many people as possible about the free beneficial concepts of .NET and JavaScript. So that was everything I have prepared for you in this video, and until the next one, I would like to thank you for watching and wish you an amazing day. Happy coding!